Okay. So, good morning, everyone. Sorry for being like 5 7 minutes bit late. So, today, like yesterday, you had Professor Bhaskar had talked about like multiple basic parameters like speed, flow, density. This is like traditionally you need to collect from the field and then calibrate your model if you want to simulate a particular traffic condition. So today our effort is that to see that like what are the basic parameters is required in order to represent the Indian traffic and how we can get those parameters. Or what are the specific behavior which is like might be very particular to the Indian traffic condition, may not be visible in the lane-based traffic. Those kind of behavior we will talk about and then how to collect the data. So this like Professor Nivjoti had already talked about, like maybe you have lane-based traffic where vehicles move in particular channels and they change these lanes, but at discrete event, not like on regular basis they keep changing. Until unless like there is some obstacle, they will not change the lane. Okay, so in the like lane-based traffic, so all the vehicles they move generally in a particular lane and they change their lane at discrete interval of time. So what while driving in these kinds of scenarios, you most of the time interact with the your next leading vehicle. So not frequently to the side of the vehicle. You don't bother about the side of the vehicle until unless you are willing to change the lane. So in this case, like once you are like only looking in forward direction, so we called it like one D kind of interaction. Like in longitudinal direction, you are interacting. So one dimensional interaction is considered if you want to model this kind of traffic, because you will be measuring what kind of distance headway is there, what kind of relative speed is there, what is your speed, what is relative acceleration, all those parameters only with respect to the leading vehicle, not on the vehicle which are on the side. So that kind of interaction we called as like one dimensional interaction, or longitudinal interaction become the prominent or dominant criteria in these cases. While if you see Indian traffic condition, where these kind of variety of traffic placement is there, so you will within the lane, you might have like different type of vehicles. So in a particular lane, if you see that like it's not that only one vehicle present, there might be multiple vehicle present, and sometimes the placement is such that it is difficult, even though lane marking is there, it is difficult to draw clear line which can segregate different people, different vehicles. Like here you can draw these clear lines, but drawing that clear line in this kind of traffic is difficult. And that is why, because of such placement, now you consider this vehicle. If this vehicle is moving, so obviously it has to interact this, it has to interact this, it might also interact this, because it's got constraint, then he has to change. And if you see that this vehicle is moving on the lane marking itself, so here it's not that like always you will be interacting with next leading vehicle, you might be interacting with neighboring vehicle as well. So this kind of interaction we say that two-dimensional interaction. So most of the Indian context, until unless you consider two-dimensional interaction, you may not able to represent the actual behavior. So you may not have only a single leader. This can also some impact. This vehicle can also some impact. So instead of having one leader, you might have simultaneously multiple leaders, and that is the makes basic difference between simulation of this kind of traffic versus this kind of traffic. Here interaction is not only limited to longitudinal direction, but lateral direction interaction is also there. That is why I called it two-dimensional interaction. So in two-dimensional interaction, so major task in longitudinal direction, you need to control that what speed vehicle will move. So depending upon the leading gap, you can decide that whether you are going to accelerate, decelerate, and then accordingly you choose what is the speed you need to move on. Then whether you are in order to maintain that speed, you need to accelerate or decelerate, or what kind of distance you need to maintain. All these are like comes under longitudinal task which you have to perform. Parallelly, you need to perform lateral task because you are having two-dimensional interaction. Okay, so this you can achieve by pressing accelerator or brake. So in longitudinal interaction can be controlled by that actions, but in lateral case you need to change the steering angle. So you will be like steering angle change might be required while overtaking or maybe while doing serpentine motion, or you want to shift lane, may not be perfectly lane. Here in this case sometimes like maybe you are not exactly behind. So in order to just overtake you need to shift maybe delta, may not be the entire lane you need to shift. So that makes the Indian traffic condition is way different than lane based traffic. So whatever basic simulation models available in for western world may not be directly representing the Indian traffic. So you need to have like this 2D interaction like incorporation in those kind of model, then you will be able to represent the Indian traffic. So apart from that, what other features we see? So how many of like you had heard like car following theory? So car following theory is like it deals with all the rules and regulations once you are consider longitudinal interaction, like one vehicle like behind another vehicle exactly if it overlaps, like in this condition the both vehicle is like exactly one behind another. So in order to define that how following vehicle will act, the car following theory is devised, which basically predict the action of the following vehicle. So this is like in lane based behavior, always you will have this kind of scenario, vehicle will be exactly behind to one each other. But in Indian context, because we are not following lane discipline, majority of time you will see that like one vehicle is followed by another vehicle, but the following vehicle is not exactly behind, it is slightly shift at lateral way. So in this case, the car following behavior or traditional car following rules may not be implemented or may not be appropriate, because whatever distance headway you are maintaining here, you may not need that kind of distance headway here. So if you see and collect the data and assume that these two are in car following mode, so you will surprised to know that time headway might be only 0.2 second. So here driver is able to maintain 0.2 second because he know that like once it is start decelerating, he will shift maybe half meter that side and then he is out of the car following behavior. So he will be moving parallelly. So then the impact of leading vehicle will not be there, and that's why he is able to maintain very less distance and still he feels safe. So this kind of behavior we say called it like staggered following behavior, where vehicles are not exactly behind one each other. Then other feature is that like sometimes you might be following two vehicles. So two vehicles, there might be multiple such vehicles. Maybe if there are three wheelers or two wheelers, instead of two wheeler you might have more than two wheeler. So idea here is that you might be following simultaneously more than one vehicle, and these are like very common cases in Indian context. Then apart from that, you keep seeing that like this bike people, they keep creeping through the gaps between the vehicles. So that people try to define with different ways. Some people say seepage, some people say filtering, some people creep through the gaps. But they, whenever they find gap, they do the serpentine motion and they keep moving. This behavior you will not see that in lane based behavior. There people will be moving on in this direction or they will discretely shift to other lane. They will not be doing this serpentine motion, but this is very common in Indian context. It's not only bike, you will see that like even four wheeler people might be doing. If road is wide enough, sometimes if you had like 4 lane, 5 lane, one direction, you will see even some car might be doing this serpentine motion. So in these cases, like if you want to study all these behavior, then a few more parameter we will talk about. Then how much lateral gap vehicles are maintaining. If we assume that vehicles are interacting two dimensionally, so now it is not only limited that you need to measure only longitudinal gap. You need to consider lateral gap because lateral vehicle is also impacting the behavior. So what kind of gap they are maintaining? In lane base, one vehicle will be here, another vehicle will be another lane. Here they are not following lane. So what kind of lateral gaps they maintain, and these gaps will depend upon multiple parameter, what kind of vehicle it is, what kind of vehicle type it is, at what speed they are moving. All those are going to govern that how much gap you maintain with the neighboring vehicle. So if you want to have two-dimensional interaction, this lateral gap information is become equally important. Then other cases, like if you see lateral placement, like if you draw one line and try to see that okay, at particular lateral position what is the distribution. So in case of lane based, you will see that histogram will, for one lane, in the middle of lane there is frequency of vehicle will be more. At the lane marking, frequency will be very low. But here if you see, the lane placement will be like entirely different. So maybe majority of vehicle, cars and those things might be moving anywhere, like might be between first nearest to divider lane. Three-wheeler might be closer to the shoulder lane, one or two lane, but irrespective of the lane marking, their presence will be felt across like all the space. So if you try to draw the lateral placement, you will not see that kind of significant peak which you can observe in case of lane discipline behavior. Then once you are like interacting two-dimensionally, so then it become also important to see that like how much lateral clearance you are maintaining, not only with the vehicle but with the infrastructure. Because if you see an urban setup, we are not following any standard height of the divider. So every like city administration, they decide some kind of divider height irrespective of what IRC suggests. So depending upon that, in order to prevent that pedestrians should not cross the road, sometimes you may see that even that height is close to 1 meter, and which significantly impact how much clearance you are going to maintain with that. If it is just like a standard 20 centimeter height, you might be moving very close. But if it become 1 meter height, you might be maintaining 1 or 2 feet gap. So how this gap is maintained and what are the factors which are going to govern. So these are the like basic features which should be represented by any traffic model which you should develop for Indian context. So in these cases now, if we list down all the behavior, so these are the behavior which we need to study. We need to see that like vehicle lateral and longitudinal movement, then staggered vehicle following, vehicle type dependent of multiple leaders. So there might be instead of a single leader, multiple leader follower, filtering behavior, how when they decide that what kind of gap you should accept to filter and when not to filter. So then like clearance maintained by neighboring vehicle, what kind of lateral clearance you maintain, clearance by the road infrastructure, and lateral placement of vehicle. These are like some list of behaviors which like should be present in any traffic model which you list for Indian traffic context. So in order to study all this, so lot many parameter is required. So how to get those parameters, because you required vehicle position, you required each and every vehicle's speed, acceleration all together. So if you require this long list of parameters, it is always better to have very basic data which can lead you to any type of parameter which you required for studying this kind of behavior. So that parameter is vehicle trajectory. So if you had vehicle position at regular interval, so then you can figure it out how much is the lateral clearance, how much is the longitudinal clearance, what was the acceleration, deceleration, everything. Even you can observe that how many vehicles are impacting your vehicle behavior. All those things can be studied. So you need this trajectory data. So now question comes like how to get this trajectory data, because sometimes like it's like one way of getting the trajectory data is drone. So you collect the video footage from the drone and then analyze the trajectory of those vehicles. And then maybe like you might be getting these kind of trajectories. So you can figure it out like what kind of lateral clearance is maintained at particular instance by neighboring vehicle. So all those features you can study if you had this basic trajectory data. So yeah, which one? This is like there are two things, like we will talk in detail. So it's minute is not important. Here duration is also important and stretch is also important. If you want to study say car following kind of thing or overtaking kind of thing, you need a certain stretch of information, otherwise this overtaking will not be completed. If you are just 100 meter, most of the car following behavior you will not able to study. So you need a longer stretch, plus duration obviously is required. So in one drone maybe like it can you can collect 15 minutes, 20 minutes. So that may not be enough because you need too many sample size. So maybe multiple drone data, one after another. There might be some gap in between, but you can collect series of like maybe 1 hour data, 1.5 hour data. Okay, so you should have at the end like a reasonable sample size for each and every like process we had talked about. If you want to study filtering, you should have enough filtering evidence in that data. So whether you get like in half an hour or 2 hour or 3 hour, that depend upon the traffic density, traffic flow, speed, location, multiple things. Okay. So this is one way to get trajectory data. What happens if this data is not available? Because that is not easy to collect the data. So then can we use some other measures like to get this information? So we will talk about this, like how in combination of using GPS, video camera and then using some kind of economical sensor, can we get some of these data or not? And then subsequently we also talked about if we had drone data, how we can get the trajectory. So in order to get the data, we can have like video camera, we can have sensor, we can have drone. So once we talk about video camera and sensors, there are two ways generally people collect the data. In one case, like your video camera can be static and placed on a pole, then you will keep recording a particular stretch of the road, and all the vehicles which are flying in that road, you will be able to get the data. So here vehicle will not fix, all the vehicle will keep changing and you will be getting the data, but stretch will be fixed. In other case, you place the camera in the dashboard of the road vehicle and then start flying on the string. So in that case, you get the as long as like length of the vehicle, length of the road you can cover, but here your pilot vehicle will be fixed. Then whatever vehicle in your surrounding, you will be able to get only those vehicles behavior. So in one case like state is fixed, in other case like one of the vehicle is fixed and then surrounding you will be able to study. You can travel 40 kilometer, 100 kilometer and then whatever is surrounding keeps changing, you will get the surroundings information. Okay. So on board and fixed at the site. Similar thing with the sensor. You can keep these sensors like at particular location, then whatever vehicle is coming, you get the information, or you can put these sensors on your vehicle and then start driving on a real traffic stream, and whatever neighboring vehicle is like interacting, you keep getting the information from the neighboring vehicles. Okay. So both of these two information we will try to study. So first thing, like we will be talking about onboard, means that sensors are on the vehicle itself. Ultrasonic sensor, this is like quite economical sensor, like it comes like maybe 400, 500 each sensor. But problem with these sensors, like they measure the presence of vehicle in conical format. So if you wanted to measure like 5 kilometers, 6 meter away, then this cone become quite big. Okay, and their accuracy is generally not more than 5 meter. Okay. So for lateral clearance, if you want to study that like how much gap is maintained by neighboring vehicle, this might be appropriate, because there like you will be studying whatever vehicle comes less than 3 meter, otherwise like there will be no interaction. So even like less than 2 meter, then Apart from that, GPS was also installed and video camera was also installed. So this was the vehicle setup where you had GPS inside and sensors like on the either side. So that time we were not having the sensor at the front, but you can have sensors like at the front, or even instead of this ultrasonic sensor, now laser sensors are there, which might be 8 to 10 meter and maybe costing around 1000 or 2000. So which is also not that costly, and maybe you can have even long range sensor, laser sensor, which might cost around 10,000 or 15,000. So that way, like you can measure like 20, 30 meter, 40 meter. You can do some kind of lateral gap, longitudinal gap study also. So in this like result, whatever we are presenting, the longitudinal sensors were not there. Okay, so this was like the V box. So this is like this equipment. Plus point is that it has a GPS. Along with that, it has cameras, and both the data is sync. So whenever like you change the position, you can figure it out what is the video feed at exactly at that location. So that way synchronization problem will not be there. This data you have to sync with this. So this has like 10 hertz data. Okay. So this was the arrangement. So you have a micro Arduino board through which like you had connected like all these like 6 ultrasonic sensor, and like all the data you can fetch in either in your laptop, or you can put my like micro SD card, and that all the data will come there. So programming is not that difficult. So that is like maybe your BTech student will be able to do very easily. So that was installed in all variety of vehicle, variety of like even vehicle changes, driver changes, and different status we run all together. So which is having different geometry of road at different location, Delhi, Gurgaon. There was like 6 to 7 such places we had collected data. So here we first result was like with the speed, how much lateral clearance vehicle maintained with the neighboring vehicle. So previously in many of the literature you can see there's a single line, which is deterministic, which is just not possible, because like even vehicle type, a different vehicle pair will have different gap, and even different driver might maintain different gap. So in this, like one thing was very clear, that as your speed increases, generally you maintain longer and longer gap. These are lateral gap, not longitudinal gap. Okay. Then we try to see that like how these things are distributed. So now you get the entire band instead of having single line. So at particular speed, you will see that like different distance has been maintained. That might be due to either driver variability or maybe vehicle pair variability. So subsequently, like even vehicle pair wise, it got segregated everything. So those details we will not go. Only our like importance is that today's discussion is that process you should able to know. Then we also studied that a vehicle, if it is constrained on either side, means both side vehicle is present versus both side vehicle is not there, only one side vehicle is there. Then what kind of lateral clearance they maintain, whether there is any change in behavior. So there was like a significant shift. So if you are constrained, it means that like while passing through between two vehicles, you compromise up to certain level on your safety, and then you maintain lesser gap and pass through. So that is like this red one. So at particular speed, you maintain less lateral clearance. Then if you are constrained by one side, you try to shift little bit like away and try to maintain larger gap. Then like other studies have been done, like maybe if this is a car and this is a truck. So if two trucks, whatever gap they are maintaining, and two cars, whatever gap are maintaining, if there is a car and truck, what kind of gap they will maintain, whether it will be average of those or it will be different. So what we had observed, that if they are similar vehicle, they maintain slightly lower gap. If there are heterogeneity in the vehicle pair, because both behaviors, maneuverability are different, they try to maintain slightly larger gap. Okay. Then other experiment where ultrasonic sensor was fixed at the site. So this was used to study that how much lateral clearance vehicle maintained from maybe divider or maybe shoulder side. So this setup like maybe was like this. So you had one ultrasonic sensor here, then another like at known distance around 20 meter, there was another ultrasonic sensor, both were connected, and here there is, apart from that sensors, you have we had webcam also. So idea here is that to get the vehicle type with the webcam and vehicle speed and lateral clearance, because this lateral clearance what we observed that depends upon vehicle type, depends upon vehicle speed. So both we wanted to collect. So as soon as like if this no vehicle is there, so this ultrasonic sensor was like keep collecting data, but it is not dumping in a particular file. As soon as they find like we had put some threshold like less than 2 meter, so as soon as vehicle comes which is closer to this, so it activates the webcam, it take a snapshot. So you get the timestamp as a file name and the vehicle type you can get. So some manual arrangement is not like automated, but this data automatically will get, one is get synced, it will try to measure the next activation of this sensor and try to calculate what is the speed. So distance is known, so you will figure it out the speed. Okay. So that way you got the speed and kind of clearance maintained. Okay. So then like for different type we try to develop the relationship like based on the median weight, based on the height of the median, and based on the vehicle type and vehicle speed. So like you can develop the relationship. Here relationship is not that important, the process is like more important, so relationship we will not be discussing here. Okay. So then using this is like one IMU sensor which gives you like roll, pitch rate and like roll rate, yaw rate and pitch rate. So how your vehicle is like tilting. So if you want to measure like say vehicle behavior on curves, so then these kind of instruments are like more important. Okay. Then lateral and longitudinal maneuverability using this GPS. So here we try to see that like how vehicles acceleration and speed and lateral acceleration changing. So this is like a different type of vehicle. So this is a speed axis and this is the acceleration axis. So for different vehicle you will see that different kind of maximum threshold of the acceleration. So one basic observation which was well known that like at higher speed you will have lower acceleration values, at lower speed you have higher acceleration values, and this is like longitudinal acceleration values, and then maybe you might have this is deceleration values slightly higher than the acceleration one. Okay. So all these acceleration, deceleration, these extreme values you might require in your simulation, that like so that you should have your customized acceleration values limit for your Indian condition. Okay. Then this is lateral acceleration. Lateral acceleration comes into picture if you do the serpentine motion. So how quickly you are shifting laterally, this lateral acceleration is going to govern, and you see that there is a significant variation with the different vehicle, like SUV versus kind of two-wheeler might be having highest. It's like goes to 2 also. No, here I think this is like at lower speed is up to 2, and then it is like less than 2. So and hatchback is slightly lower. Here three-wheeler like is giving even higher value. So this depends upon like how much serpentine motion you are doing. So more the serpentine motion, you might have higher lateral acceleration values, and these are not at the curve. These are all at mid block section, excluding all the intersection data, and that is like 2 lanes. Similarly, we do it for multiple lanes, and we see that like as lane width increases, like or maybe road width increases, your serpentine movement sometimes reduces because you have enough width. Then we try to plot lateral acceleration versus longitudinal acceleration and try to see that like using this friction circle concept whether all the movements whatever you are doing is safe or not. This is like on one axis longitudinal acceleration, on other axis lateral acceleration, and these are the circle which tells about that based on the coefficient of friction of the road what is the extreme value you should take. If you are going beyond this circle means there is like certain amount of risk involved, and this is like still they are safe because like whatever IRC value says that coefficient of friction that automatically accounts certain factor of safety. So but like in extreme weather condition if you are doing same kind of serpentine motion you may not remain same if your value is outside of the circle. So in that case we had observed that two wheelers were having much more serpentine motion than other vehicle. So these like analysis like gives you an idea that like here if you do in lane base you will see most of the data might be within the circle because they don't do serpentine motion, but in this cases like you keep seeing even on mid block road they keep doing lateral movement significantly. And this like in a two wheeler case it is like 3%, more than 3%. So and this circle dia keeps on decreasing at higher speed, which means that at higher speed you do less serpentine motion, at lower speed you do lot of serpentine motion. Okay. Then camera at fixed site. So here camera at fixed site give you this kind of study like where vehicles are flying, you can get vehicle position, so you can figure it out how much is the lateral stagger between the vehicle. Okay. So these kind of things like are can be helpful in studying the longitudinal behavior where you can measure like what is the longitudinal gap, what is the lateral separation, and then what is the speed of the vehicles. Okay. So like this was like taken from one building. So you can have virtual sections and get everything. Okay. So even trajectory data, in order to process that video either you write your own code. So you had the video, then this vehicle trajectory has to be here manually extracted. So either this is one tool which is available in public domain, or you can write your own code. Now in even MATLAB they had lot of image processing tools which is inbuilt. So that also you can use to extract the trajectory data. These are like the kind of algorithms which correlate the image coordinate versus real world coordinate. So if you in real world like maybe you need to have this kind of calibration circle rectangle. So these dimensions has to be known, and at the same time in video recording should be done. So in image also like you need to click on the same point. So based on using the formula you will be able to develop the mapping that image dimension how it is matching with the ground dimension. So this is like mandatory, you need to have before starting data collection you need to have this kind of calibration, because if angle like camera angle and zoom angle everything changes, this calibration changes. So once calibration is done you need not to change the camera angle, position or zoom amount. So that has to be fixed and then your calibration is done. So you can place the camera on the top of vehicle and keep moving. Then with that whatever is the next vehicle you can figure it out what is the longitudinal gap. So even many of ADAS like which is based on video they do like image processing things and keep collecting that what kind of longitudinal gap they are maintaining at particular location. Okay. So this is like one tool which was developed by one of my PhD student in MATLAB. So which is like similar way where semi-manual you need to click the vehicles and then every only plus point is that nothing you need to note down manually. If you click, position is automatically get dumped in particular file. So if you click on 3 edges it will give you vehicle width as well as length and the position. So similarly if you click this and click this, so automatically all longitudinal and lateral dimension, you will get like what a kind of lateral separation they have. Okay, so these are few other sample video. So automatically this x, y, z and all those parameter will come in the particular file, and you can get what is the longitudinal gap, what is the lateral separation, means like if you draw center line of this vehicle, center line of this vehicle, how much lateral separation are there. So if this lateral separation is more, so the impact of leading vehicle will be felt by the following vehicle is less, because if you are this, if it becomes 0 means you are exactly behind this vehicle, then the maximum impact you can feel. If you are staggered little bit outside, you will feel less impact, you will maintain less longitudinal gap in that case. So this is like the kind of graph. So here perfect car following is like close to like this, where lateral separation is less than 0.5 meter. So almost like you are exactly behind the leading vehicle. Then this kind of distance headway, a time headway you maintain. But this time headway keep reducing if your lateral separation increases. So you are able to move more closer. Okay. Okay. Similarly, this is like related to speed. So once you are exactly behind with the similar kind of gap, you might be maintaining lower speed. If you are slightly shifting sidewise, then you will be able to maintain slightly higher speed. Okay, all those like, then all sorts of modeling you can do, what kind of longitudinal based on like what is the lateral separation, center line separation, what is the time headway, how it got distributed with different vehicle pair. If big vehicle is in front, time headway will be different. If a smaller vehicle comes, time headway will be different. So all these are like part of research, so that you can figure it out. Then if you keep changing center line separation, you will see that like TTC, whatever is like with the traditional definition, that requirement will keep reducing. So even as per definition, maybe you might see that this TTC might be very dangerous, maybe 2 seconds or less than 2 second TTC, but because the lateral separation is high, they might be moving comfortably. Okay. Time to collision. So like it's like distance divided by relative speed between the leading and following vehicle. So if relative speed becomes 0, TTC become infinite. So it tells you that how, before hitting the next vehicle, how much time you have. Okay, so it should be larger than your reaction time, so that you should be able to react and change the your vehicle statistics. Okay. So then filtering maneuver. So from the fixed camera, we try to study different traffic stream and try to see that like how the filtering maneuver is taken place and what kind of gap they accept, what kind of gap they reject. All those things can be studied in this. So in 2 leader, this is filtering, that is like filtering by car. So then like once you get all this data, like how many what kind of gap got accepted, what kind of gap got rejected, then you can make your own decision model, that if you wanted to develop a simulation model, every time there might be 2 vehicles, you need to tell them whether to overtake or filter between the vehicles or not. So for that decision you need this kind of model. So from the real life data, you need to know that when a particular vehicle has accepted the gap, when he has rejected, based on vehicle type, based on the gap available, based on the even vehicle type where between which gaps are available. If say like 2 meter gap is available between 2 trucks, you may not feel like going through it, but if it is two-wheeler, you might feel like. So that way all those parameters like will come in the modeling, and then you can have your decision model. Okay. So then even you can use the same video camera to figure out the lateral placement, that where the vehicles are laterally placed across the width. So if you plot that lateral placement, so here these peaks are there, but in between like you will see that this is not 0. In some cases it is like still the peaks are there. So clear cut peak you will not see in our case of traffic, where the interaction is 2D. Okay. How much time? So this is 1 hour, no? This schedule is. So we need to complete it. Then onboard camera, where camera is like within the vehicle, then you do this kind of calibration, and then this vehicle can keep moving and you can keep collecting data. So these are like a economical way to study the car following behavior. Otherwise, you require a lot of sensors and those things. If you don't have, you just have camera, then you can do the camera calibration, and then you can run in traffic, real traffic stream, and keep collecting data, what kind of longitudinal gap you maintain with the how much lateral separations are there. So this was done like with another PhD student, where like all these are probe vehicles. So even leading vehicle are also at our control. So the driver were not aware what we are doing, but like the volunteers, they were like instructing them what speed they have to maintain, because we need at all speed what kind of longitudinal gap, lateral gap is maintained. So sometimes this left vehicle is ahead, sometimes right vehicle is ahead, and then whether there is a gap change or not. So multiple run has been taken, so that at least some kind of driver biasness get neglected. Okay, then you can do all the analysis. So like here, this graph was used to figure out what is the driver reaction time. Once the leading vehicle start moving faster, how quickly the driver has reacted. Okay, so these are like the team which was involved. So this Dr. Sanhita, who is like faculty at IIT Roorkee, then Dr. Geet Mukta, and then Dr. Anuj Budkar, who is in IST. They were part of that, like whatever results we had shown. So all the hard work is done by them. So only we are just like mentoring them. Then now it's like any question till now, whatever we had discussed. Yes. Average stretch of road means like, in what sense, like width or length, for what kind of a study?
Just one sensor.
No, so here stitching is not required, because like you are getting continuous data. For that instance, you are getting what kind of lateral clearance is there from the sensor, and from the GPS you are getting what is the vehicle statistic, like at what speed is moving, what acceleration was there. So your own vehicle dynamics is known. Then neighboring vehicles, like maybe because we are three sensor, if a vehicle is like moving like this, you know that like when this vehicle has hit the sensor 1, and once if it is like overtaking, so then you might be also getting when the third vehicle got third sensor got activated. So sensors like in between distance is known. Even you can figure out what is the relative speed of that vehicle. Your vehicle is known, so relative speed of this vehicle is known. So you can figure out indirectly what is the speed of this interacting vehicle as well. So you know your vehicle speed, interacting vehicle speed, and the gap. So here length is not a like consideration. Length, like it depends upon how much data you want.
Okay.
So if you want like 500,000 interaction, so you need to keep running till you get that many interaction. It depends upon that surrounding vehicle. If surrounding vehicles are less, then you need to run longer stretch. Otherwise, you need to maybe run a lesser stretch.
Thank you.
Yeah. So what does constraint, unconstrained mean? That is simply following the car method, or describe the traffic only on one side does not mean that two vehicles travel next to. This constraint here is like more we look up for like lateral constraint. So if on one side you have one vehicle and then you are interacting, on other side is free, then we consider as unconstrained, because like you have freedom to shift on other side. Then you can whatever lateral gap you want to maintain, you can achieve. But if other side also a vehicle is there, then you cannot shift on this side. So that become constraint on either side. In that case, like lateral gap whatever is maintained, that is lower than unconstrained side. Any other question from online? You can just unmute and ask. So Mrs. Anupma, whether like your question get answered?
Yeah, got it, sir.
Okay, thank you.
Thank
So
you.
now we'll move to the drone data collection. We have just like maybe 10-15 minutes will take, not more than, otherwise like your lecture will get squeezed. So now in other case, like if you had got trajectory data from a video camera, that is like not from drone, that is the best thing which you can have. Then all this arrangement you need not to do. So this we can skip. So while collecting the drone data, first you need to see that where to collect data, because everywhere you may not get permission to collect the data. So you need to consult with the DGCA website, that which is like marked in red zone, yellow zone, green zone. So in red zone you cannot collect the data. In yellow zone there might be height restriction. Even green zone you have little bit more liberty. So you need to see that the stage we are planning the collect the data, whether it falls in that zone or not. Like here different height restrictions are there at different zone. So red zone like maybe Lal Killa and those places, you cannot collect the data because those is like historical monuments and high security area is there. So mostly you should try to collect in green zone, and this like until unless you get proper permission, it is difficult. So that is the major challenge than collecting the data, getting the permission. Okay. So once you got the permission, you can in order to have car following study, you need longer stage. So one drone, if it is like a reasonable height, so you can collect maybe only 150 meter to 200 meter stage up length. But this 150 to 200 meter stage may not be sufficient for call following study. You need at least 500, 600 meter. So for that, like maybe you need to deploy multiple drone to collect the data. Okay, so maybe first you once you figure out the stage, and if you want like this kind of longer stage data continuously, then you need to deploy multiple drones simultaneously. And here precaution is like required to some area should get overlap. So at least like you should have 40 to 60 meter overlap between different drones. If overlap is not there, you will not get continuous trajectory. So that is like one important criteria. You should have this kind of significant overlap. More the overlap, accurate trajectory, like accuracy of trajectory will be better. But like this is wastage of resources. If you had 100 meter overlap, so even with the 3 drone, you will be able to get less length of a trajectory. So here every like drone will be like collecting data simultaneously for 15 minutes or maybe 20 minutes, and they are like expert. Now they will figure it out all the GPS coordinate, and as soon as they fly next drone, they will put that GPS coordinate. That drone will automatically get fixed at the same location. Okay, so that way like subsequent drone video whatever you will get, things will not change. They more or less they will remain similar way. Then once you like collect the data, you will get the raw video data. There maybe you can first thing you need to do is that like maybe you need to stitch this data, stitch these videos, because like this video 1, video 2, video 3. So there is like either you try to stitch the video or you get the trajectory and then trajectory get stitched. Okay. So in this case, like we got the trajectory, and here also some calibration is required. Like in the ground, you should have control points whose longitudinal actual dimension is known on the ground. Same thing will be required once you try to extract the trajectory, which we had discussed in camera based thing, because this is also camera, only thing camera is on the top. Okay. So that kind of calibration methodology you require, and here the data was collected, I think from data from sky. So like this data from sky is like a kind of commercial website if you upload the video, they will able to extract the trajectory and give you the trajectory at certain cost, but lot of post processing is required in order to ensure whatever trajectory you got, that is correct. Okay. So in this case, this was the kind of vehicle distribution. So you could see that like these are different, all variety of pairs we are able to collect, because this is highway. So two-wheeler percentage was not that high, the car percentage was significant, and truck percentage. Now once you get trajectory data of like drone 1, drone 2 and drone 3. So if you start placing, so you will see that there is a band which overlaps between different trajectories. So here, although it is like it's not zoomed, if you zoom it, you will see that one trajectory may not match with the other trajectory at the overlapping portion. So this like, but actually vehicle might be one which might be moving, and in order to stitch this trajectory, there are few other criteria you need to see, that like to identify that a particular trajectory whether the same vehicle belong for this trajectory or some other trajectory. So there you need to do certain kind of constraint. First is that pair to pair vehicle match, because the trajectory, if you are getting the same vehicle trajectory, vehicle class will be the same, that is first match. Then you need to have that like this trajectory, if it is like at this lateral position, so maybe within plus minus 5 meter the other position will also be there. It will not be 5 meter away, it will be very close. So once you like search if there is any trajectory available within 0.5 meter and vehicle class is also matching, even longitudinal position is also matching within certain range. So these like ranges you need to fix. So if you had two small range, you will see some of the trajectory will not match, it will remain like unmatched. So then you relax a bit the criteria, search for more neighborhood, because if error is more, so maybe your trajectory, like one trajectory from the one drone video and the trajectory might be here. So there might be some error. Once you have this drone data collection, so more higher accuracy will be at the center. As you move outside, your accuracy will get compromised. So the trajectory information towards the end will be less accurate. So this drone accuracy, trajectory accuracy will also be less, this also less. So there might be chances there is a mismatch. And then like with certain constraint, you if you are able to figure out, okay, this is the same vehicle, this is the same vehicle, still you will see that trajectory will not match. There will be some difference, maybe 0.5 meter, maybe 0.2 meter. But how to make it continuous? Because at the end, like you need a single trajectory for entire all three drones. So in this case, like whatever we had adopted for this trajectories, accuracy of this trajectory will be high here in comparison to at this location. Similarly, for this trajectory, accuracy will be high here than this location, because it is recorded from this side. So here it will be least accuracy, here it might be slightly better. So assumption was made that like here we will assume that this trajectory is correct, and here we will make that this trajectory is correct. Now you can do the kind of linear interpolation between the gap and make the clear trajectory. So although this is like one attempt, there might be multiple other attempts possible. So that is like up to you. You can experiment that how to join these trajectories like from one drone to another drone. So then once that trajectory stretching is done, you can have continuous trajectories, and you can have this continuous trajectory like over entire 600 meter or 800 meter, whatever you want. Okay. Then once you have, because it's like trajectory will have certain error, because like once you do image processing, you may not get 100% accurate result. So then some kind of, these are like smoothened trajectory, the zoom view of the same. Then some kind of smoothing is required, because you will have noise. So if with this data, if you try to compute with the raw data acceleration, so you will see that like two acceleration values are positive, suddenly become one become negative and again become positive. So which means the vehicle is moving ahead and suddenly moving back. So in reality, it will not happen. So all those things needs to be removed or maybe like calibrated. So you need to adopt like different smoothing technique and see that like which one is like the best one. So there are many ways to do that. Like you can have, while collecting the data, you can have your probe vehicle which will keep running. So you have GPS data, and then based on that, like you can do calibration, or you can adopt different like filtering techniques or like smoothing technique, and then you do the statistical test and adopt that which one is the best for your data. And once you have these data, then it's like your raw data is ready. So now you, whatever parameter you want, you can write a code and collect like what is that particular instance. If a particular vehicle position is this, what was the neighboring vehicle position? So longitudinal gap, lateral gap, relative speed, everything you can get, and then this become like very basic data for your modeling, which like might be necessary. Not only developing the model, once you develop the model, you need to calibrate. So if in order to like do what kind of lateral acceleration values in field it is available, you need to match with your simulated trajectories. So maybe like out of maybe 1 hour, 1.5 hour video, you keep like maybe half an hour video for only validation. That will not be part of the simulation development. So once your simulation model is developed, the remaining part you use for validation. So then you can see that like whether your trajectory, simulated trajectory is matching with the observed trajectory or not. So that way like you can do. So this is like some of the statistics which we got for this data. So maybe these are the vehicle count for different types of vehicle which we observed in that our collected data. So maybe as Professor Bhaskar was saying that currently this work is going on. So once that work is completed, maybe this then become public. So but it will still take at least 1 or 2 years, because so Surya is there. So he is the person like my PhD student. So he is working on that. So maybe like once he is completed all our research work, then we will be able to make it public. So then rest is like just like kind of extraction and some representation of the result, like what kind of longitudinal spacing versus density, many other things. So this like maybe better we can skip. These are the gap on right side, how the gap is distributed, on left side how much gap is distributed. So lateral gap on left side, right side, all those things. Lateral placement. Now here you could see that there is no lane marking is there. In some cases you see the peak, but peak does not get synchronized with the lane marking. Only on median side always you will see a peak, because median side there is like vehicle cannot go beyond that. So always you will see that a peak on that side which might match. Okay, so these are like the fundamental diagram. So you can see that like data is available from free flow to even towards the capacity condition at certain time window. So this data was like I think 1.5 hours or sorry 5 hours data. So that's like significantly large amount of database. This is like flow and speed. So this might be the capacity. This is like 4-lane road. Okay, and this is like I think still in vehicle PCU per hour. So it's like maybe standard IRC method they had might be adopted to like convert into it. So whatever capacity is observed, that might be for 4-lane, 5-lane. So this is like the person. And then now any question till now? Yes.
Yes, sir. I would like to ask a general question.
Yeah, please.
It is a very interesting study that you have shown that about the heterogeneous traffic behavior and the way our traffic, follows a serpentine motion, and they I mean, do not follow the lane changing, the vehicle following behavior. And this kind of behavior obviously has certain risks. And although the time of travel may be reduced in some cases, but what I'm trying to ask is, I mean, from this analysis, are you able to give some kind of recommendations to the authorities so that they can plan the network in such a way so that the heterogeneous traffic behavior itself is sort of corrected? I mean, the serpentine behavior is reduced. So, is there some kind of recommendations which you would like to, which you have sort of come out with and may be useful for the authorities to implement to improve the heterogeneous traffic behavior in the Indian conditions?
Okay. So what we can do from this data, that we can figure it out what are the situations where risk is more. So maybe that similar kind of behavior can be implemented in ADAS and those things which can make you safe. But regarding the heterogeneity, so and serpentine motion behavior, these behaviors like automatically get corrected as homogeneity increases. Like if you see if car percentage increases, so you will see that like lane behavior automatically coming up. So instead of, they might be, instead of 4 lane which are marked, they might be maintaining 5 lane, but some kind of lane behavior is there. But if there will be like heterogeneity in the traffic composition, then whatever you do, if you implement lane behavior there, the system will not be efficient. So whatever capacity we are going to achieve, we may not achieve that kind of capacity. So we cannot like it will not be economical that in one lane just only one three-wheeler, or maybe one not three-wheeler, maybe two-wheelers are moving. So there might be either you segregate the smaller vehicle at the side, that could be one way. So then maybe you can without compromising on the capacity, you can achieve a safe system where like a smaller vehicle will get segregated, or vehicle with the slower speed gets segregated. Otherwise, if traffic composition is like that, so it is always economical to have the no lane discipline behavior instead of insisting them like to follow the lane discipline. So yeah, obviously some of these outcomes like will related to safety, that will definitely come, that what kind of gaps we observe, whether how safe it is. So what can be things can be done. So based on that learning, maybe either subsequently you can have safety system like ADAS kind of thing, which can keep on warning the driver that whenever like you cross a particular threshold. Okay. So is that like your question is answered?
Yes, sir. Just I mean, supplementary question. I mean, what do you think of implementation of BRTS? Like BRTS, obviously we restrict the lane for maybe buses, or maybe we can add some of the heavier vehicles along with the buses. And this is normally opposed by some of the people who are using cars or two-wheelers, as was seen in Delhi, that it was not very successful, although in some other cities it has been successful. So what's your opinion on this, sir?
Yeah, BRTS is like nowhere related with this current discussion, but like BRTS has its own pluses and minuses. Like because most of the time BRTS lane is towards the median side, accessing the like by the passenger, that is like another challenge. Like there is always a debate that where to keep this BRTS, whether on median side, shoulder side. Then maybe like it's not justified, because this work is not related to BRTS. So maybe I will not make comment on that whether BRTS is appropriate or not. Yes, like if you are using or promoting public mass transit system, it is always better for future. So you don't require like basically too much wide road if your BRTS systems are working fine. Okay. So thank you. Yeah, please.
In that slide where you have mentioned three drones and there is a overlapping distance 20 to 60 meter. What is the conventional practice of maintaining this overlapping? Is it maintaining lesser distance is appreciable or maintaining a larger distance is appreciable?
Okay. So if you had lesser distance, so chances that like you are on the extreme end of the your video where errors are large. So then once wrong trajectory, like means error is means like the trajectory is not correct, and your this trajectory is also not correct. So chances is that like once you try to join, there might be a kink, sudden change in the behavior, and if you do analysis based on that, and many of the time values will not be the realistic one. So in order to avoid that, you need to have overlap. Now, if you had higher overlap, it's always good to have a very good accuracy, but you are losing your stress. So you are applying 2 drone, but you are getting 300 instead of maybe we can get 350. So that is why like you need to make some kind of compromise as well, like somewhat like you are compromised on accuracy. Sometimes you are compromising on like because you want to increase the efficiency, you want longer length stretch. So 40 to 60 meter was like from the literature also it was observed like reasonably good because whatever trajectory we got, so at least we are like able to that is trajectory data is able to pass all the minimum test what is required for any trajectory. Okay. Yeah, yeah.
In terms of PCU. So why are we using PCU in this study? Like,
Yeah.
is there a reason?
So area occupancy, how comfortable you are yesterday, whether you are able to understood all the complication what area occupancy had.
A bit of it, like because I'm not from an engineering background, so it was a little
Even
harder.
engineers find it even more difficult to visualize because people are like more conversant with the density. So yes, like for all research purpose, area occupancy is fine. But for our practical purpose, if you go, people will not able like if we say area occupancy is like 8%, you have no idea that how much congestion will be. But if I say V by C ratio or like maybe flow value is this much PCU, at least you will have some idea that capacity is this much. It's like closer to that, maybe level of service, you will be able to guess whether it is B or C, and then accordingly you can have some congestion. So that is why like still once we say area occupancy, it doesn't mean that the density is like useless.
So there aren't any standards like still on area occupancy or related to LOC.
There is, but it's not that well researched.
Okay.
Okay, so in code you will not find area occupancy.
Okay.
Because you need large scale data collection and then conversion, and still area occupancy visualization is still not there. So it's like it has to go long way in before we accept area occupancy as one of the valid parameter which is like used in the ground research. So still it is like in the research community itself. Yeah.
Other than this, is there any other studies which it has been carried out in urban areas?
Regarding
Yes.
drone one.
Because
At-
in Bangalore they have a flyover,
Hmm.
the metros.
Mhm.
It is very difficult to get an aerial view completely.
So problem is getting permission. So permission is an issue. So we planned it to collect in Delhi, but we could not get permission in Delhi. So we collected data from wherever we got the permit. Forget about green zone. There were too many green zones, but you will not get. They will simply not allow because they fear of like something. If something happen, who will take responsibility? And in the name of that, they are considering it will remain considering like even a year. So I think he had spent a week while going back and forth with the office, and then we decided that better not to go to office. Drone people, that company, they said like I will tell you where I can collect data and give you without any permission. So that is the actual condition. So you need to like compromise somewhere. Like maybe that stage actually we were not thinking of. We are thinking of Delhi Gurgaon Expressway. So where like you have lot many traffic, but permission was not given.
Any calibration factors that we can try, because already lot of study you have carried out. So from that particular point of view, we had
Calibration factor regarding
means for the urban areas, like I told you, where the zones which we are not able to collect the data. Can we predict something with based on this particular?
little difficult. Like I said, na, constrained one. So in constrained condition, things changes because like you are human, how much risk you are going to take. Until unless we have observed data, it is difficult. So in urban setup, you need real data before telling any that like how much compromise people do in order to optimize his travel time, because here they are going to reduce their travel time on the cost of safety. So they will be moving in the narrow gap with higher speed, compromising on safety in order to reduce their travel time. But how much they compromise, that is difficult to tell with this data, at least until unless you have real data from the field. But the sensor data we had like from urban area, very well from the urban area. From there we can have some idea that okay, here lateral clearance is of that order. What is the lateral clearance in the urban set? So there we like those kind of setup you can use to collect data where you don't have drone permission. Okay. Yeah. So yeah, quick question.
Can we correlate this data with the vehicle infusion in our like this
Uh-huh.
what is the effect of these data in the vehicle infusion?
Might be because like maybe there it is like uh, due to constraint you are like once you say work zone, basically I perceive in a way that like congestion condition. So you want to shift the lane. Yeah. So there maybe like you might compromise on the safety. But like that is like if you had congestion condition data here, so that might be work out to simulate that kind of condition, that in constant condition how much gap they maintain, lateral gap they maintain, then you can apply some kind of like gap acceptance formulation shifting laterally, and then you can simulate. So this data might be help certain extent. Okay.
Yeah, I think one also issue is that in India, especially, the transition zone area, which is now properly
Maybe you can come, otherwise like it will be delayed.
many of the transition happen there in the transition.
Excuse me, sir.
Hello.
Sir. Yes, sir. I have one question regarding the camera calibration technique.
Okay.
Where you mentioned that we need to calibrate it.
Mhm.
My question is, like, do we need to make a grid uh, on the video to calibrate it, or is there any other technique to do so?
Yeah. So whatever rectangle I said, so that is actually a grid, or maybe sometimes you might have like a kind of checkerboard or chessboard kind of grid. So basically, more number of grids you have, your calibration will be like more accurate. So if you had able to place the grid in the ground, so all the dimension is known, and if the same has to be recorded in the video, so then you will be have better calibration. So here we are having only 4 corners and 4 dimensions to calibrate. If you had a grid, you might have many more dimensions to calibrate. So that will be even better.
Okay, thank you so much.
Okay, thank you.
Sorry to interrupt. One question from my side.
Yeah.
So here we have seen like many data collection methods. So my question is that for any real world problem, like do we have some standards like for such kind of problem we have to go for this kind of data collection method?
So here instead of problem, maybe based on the problem, we need to figure it out what kind of parameter is required. Then once you are able to zero down with the parameter that maybe you are interested, like that problem might require only longitudinal data or lateral data. Based on that, then you can map through the different practice that how to collect that parameter in the field. So that is like better way to correlate.
One last quick question. There's something called ANPR, automatic number plate recognition, where we will collect the data. So how does that work? Like the post processing or the extraction of the result, and until we put the data into the model, the simulation we carry out later. So how does that work? Like, could you give some idea about it?
Yes, automatic number plate recognition system. You can like this is additional information if you had video processing system. So video processing system, like they can give you longitudinal distances and those things correct, but sometimes vehicle classification may not be correct. If you have number plate recognition system, that data can be mapped with that. So because like if you have number plate, you can exactly know that what model of vehicle it is, and that will like have additional information to like ensure that there is should not be any misclassification from your data. So that is like, but independently only number plate recognition system can give you the flow value, that how many vehicle has passes from the particular location, what are the type of vehicle, then based on that you can apply PCU values. So flow you can get, but speed and those things you will not get from that instrument.
Okay.
Okay.
Thank you.
Okay, thank you.
Maybe we can give them 5 minutes break to go and grab the cup of tea.
So just Daniel, see that like tea break is scheduled to at 11 o'clock or something.
No, 10 o'clock.